So again, my apologies for perhaps sharing incorrect information that was modified recently on the discussions. I shared that one of the bigger differences between a section component and an aside component was that asides you can collapse, but sections you couldn't. Um, Dwayne recently made it so that you can add a collapsible attribute to sections as well. So now that's one point of similarity instead of difference.
So
Um,
except it doesn't isn't quite in there yet.
what I said will be false at some point of time in the near future. It's in this gray area right now.
Yeah.
But thank you for pointing it out in the documentation. I wasn't even aware that Dwayne had placed it in there. Um, Second, we kind of left a hanging question about the pedagogical benefit of pretzels, other than, and I think Spencer might have called it whiz bangery, and I hope to have opportunities to use that phrase more frequently. Uh, it really is just decorative. I've taken a standard worksheet of 10, 12, some even number of questions and converted into a loop. And for whatever reason, based on feedback over 4 semesters of using pretzels or circuits, students seem to like doing them a lot more. The pretzels with distractors or salty pretzels have gotten even better evaluations from students. But yeah, it's I think either Chrissy or Matt Bolkins said that I had found a way to cheese the broccoli, and it really is just that. I wish I had come up with a phrase, but again, you're just presenting the same exact thing to them in a different manner, and that seems to keep them entertained, which I'm happy about. Okay, those are the two things. You've already met Melissa. Virginia is new to the workshop as of today. Virginia, do you want to share a bit?
Yeah, so I have worked with Dwayne for about 5 years now, since the very beginning of Donut when we didn't have any documentation and I just had to go to a Cypress test and try and figure out what each component did. And so I really, really just enjoy the creativity that you can get kind of immersed in the authoring experience and basically create whatever you want. So, um, that's my role.
If I can't figure something out, I'm either going to Virginia or Dwayne. And if they're both busy, then I'm just complaining louder. But thank you for joining us. Today, Melissa, I think, is going to start us off with references, and then Virginia will take over in the second half and talk to us about randomization. Again, for anyone that maybe was checked out, there's 3 links in the chat. The first one is for the tasks from yesterday. Um, the second link is the task list for what we hope you'll accomplish after the session today. They are connected in the sense that if you haven't had a chance or if you didn't get to work through the day one tasks, we urge you to do the day one tasks first and then move on to the day two tasks because some of it is going to be modifying those things. So, well, you get the idea. Foundations first, and then you start building your tower on top. All right, with that, I will stay quiet and Melissa, take it away.
All right. So, like Anurag was mentioning, today you're going to learn about doing randomized problem versions later on with Virginia. Before that, we're going to talk about references, which are this like sneakily powerful thing in Donut, which makes so many cool things possible because it makes it so that you can kind of link things together and make it so that changing one piece of the activity affects something else, and that creates a tremendous amount of power for what we can do with interactives. I will start a screen share here. Like yesterday, we're going to start off with uh, beta.donut.org and looking at the scratch pad. So we can click the start writing button here to get to that scratch pad. And of course, I've got all the Zoom stuff in the way now. All right, so we're going to start with looking at uh, mathematical tags in Donut. So second from the bottom here. and see our different options here. So some of these you saw yesterday, so should be familiar, but are going to focus on some important differences between different kinds of math tags here. Last
Melissa, could
time,
I interrupt you quickly?
yep. Mhm.
I'm looking at the suggestions for what could be done better or differently. If you're having a hard time seeing the text that's on the screen, one very quick thing you can do if you have a trackpad, you can literally zoom into the presenter screen. Or if you don't have a trackpad and you're using a regular mouse, you can also use the like click on the screen somewhere on Melissa's screen, and then the keystrokes are Command and plus or Control and then plus to zoom in.
I just made mine a little bit bigger here, so hopefully that's a little bit more visible. All right, so kind of over on the right here, again, we're seeing that rendered document and then our code or markup on the left here. Something to note that's kind of nice is that we also have this little helper box here. And so if I click into something, it'll tell me about it so that I'm clicked into inside of that M tag there. And so it's telling me this is an inline math rendered with LaTeX. And if I want to learn more about that, I can click here to go to the reference page, and that will take me to the documentation. So that can be a quick way to get to more information about a component, go straight to that part of the documentation, which is really, really awesome looking at the examples and different possibilities. I find it so helpful when I'm working on an activity just to see those examples and what the possibilities are. So we get that for tags. If you're kind of not in a tag, but here we're inside of this line item component here, it says that I'm inside the line item and gives me some suggestions of things that I could try putting inside here. So I could add a paragraph, a math expression, or even a graph if I wanted to. Graphing will be covered more tomorrow. So something exciting to look forward to there. And if we want to look at, say, an attribute for something, um, we can start typing that, and then we see the attribute explanation there as well. So that can be a nice quick reference for information, and then also has the link out to the documentation with quite a bit more information and examples there. So a little bit of a tangent there. All right. So we're going to be looking at kind of two tags in particular here, the M tag and the math tag. So the M tag looked at more last time. So the M tag is for displaying math. So right in LaTeX, see things like our frac with the angle or curly braces, that's the one, and get that to display how we want there. So think of the M tag as we're just displaying math, we just want to show it. We're not doing any computation with it. But if we want to actually do computations with the math that we're using, that's where we want to use the full math tag as opposed to just the M tag. So when we're working with this, typing in stuff is a little bit different. By default, it's not going to use LaTeX, but we can make it use LaTeX. So it'll be a little simpler for typing things in. And then this is kind of unlocking all of the power of a computer algebra system. So we'll be able to do things like simplification and a whole bunch of algebra stuff that gives us a lot more that we can do with math things. So uh, A big part of this is looking at things like simplification and expansion. So this is important for looking at answers because sometimes you might want to not give credit if a student doesn't simplify their answer, for example. For if the whole point of the problem is that they're supposed to be expanding a polynomial, well, you don't want to give them credit if they're just rewriting the polynomial in factored form. So this is something that we want to be able to control, and so we can start to see that with simplify and expand. So, for example, here we've got x plus x. We've got that in two different math tags here. In the first one, it's just as x plus x. In the second example here, now we're using the simplify attribute. And so then we see that it now simplifies that to 2x. Uh, when we have x plus 2 times x plus 1, and simplify that, well, it's not totally clear. Is it simpler to have something expanded or factored? And so it leaves that as x plus 1 times x plus 2. So instead we can use the expand attribute. That's down here. And then we see that that expands that out as x squared plus 3x plus 2. If you are really a die-hard LaTeX person and want to use LaTeX in your math tags, you can do that. You just have to use the attribute format for the math component and set that to be LaTeX. And then you can have your fun backslashes and all that stuff rather than saving time by not typing those. So you can do it, but you don't need to, and the default is to not have that with LaTeX. Um, so uh, with that kind of quick introduction, we've got a few tasks for you here to get started. Um, So I'm gonna switch windows. Not good at getting the slide up. I'll put these in the chat as well. All right, so I'll give you maybe 5 or so minutes to work on these and see what you can come up with.
And is this happening in the Scratchpad? Or are folks creating a new document?
In the scratch pad is fine. So you can just kind of add on to that example that we're working with, the mathematical tags and donuts, so you can still refer to those other pieces that were already there. And if you're not sure about something, you might try starting to poke around the documentation and see if you can find something there. Ooh, thank you for starting the timer. I love that music. Such a beautiful ending to the work time.
I'm wondering if I should turn it off. I don't want to scare anyone into, or if you're in flow state, I don't want to get you out of it. But we'll
How
keep it
are
like that.
how are people doing with that? Do you need more time or are we ready to go?
Yes, sir. I'm still working. I there's in the documentation it says there's an attribute for math called numbers preserve order, but then I I get an invalid attribute when I try to use it.
Hmm.
I don't know if that's the right one, the right thing to use for the I think it was number two.
Yeah, so we had a
But
different one in mind here
ah,
for that.
Is it
Before
Yeah.
we
simplify?
go on,
So
go ahead,
the
Clark.
attribute is simplify, and the value, I think, is the the string that you were talking about.
Mhm.
ah,
Oh, okay. So right, it's not an attribute itself. It's
it's
the
a
value for the attribute.
got it. Is that still not the right?
No, that is yeah. Yeah.
Hmm. It didn't seem to do anything to it
It
though.
actually isn't.
Did
Hmm.
I
It's normalize order.
Ah,
Numbers preserve
Oh,
order
right.
will
Okay.
do something else that
I
might come
was
up
looking
later.
at the chat and
normal disorder. Okay, got it.
When you say normalize order, where does that go? Because I tried that and I got an error.
all right, let's go ahead and start talking through these. So I just cleared the scratch pad and started off a section here, put in a title for the tasks, made a ordered list, and started a list item here. None of this is necessary here. It was just creating a little numbering for myself. And so we'll have math starting out because we want to do some computation. We will use our math tag instead of the M tag. And we're not doing underscores, we're doing addition. And we're trying to simplify 3 plus 2x plus 4 plus 6x. So first off, how do we simplify that?
You give the inside the math tag, you give the attribute simplify.
Mhm. Yeah, so once I start typing it, we get that nice hint there. And we've got the description down here, level of simplification applied to the expression. And if we scroll further down here, you'll notice that it has allowed values. You can also get to this through the documentation. So we do see that numbers preserve order, which I'm curious about. Simplified. I have no idea what that means, to be honest.
I've
But yeah,
used it a
norm.
bunch.
Uh-huh.
If you're teaching like not what Melissa's teaching, but you're
Right.
teaching very very low level stuff, if you have an equation that you're generating coefficients for, so for instance, the coefficient of x is the sum of two numbers that you've determined based on some student input or you've done some randomization, then what you might want to do is say keep the x where it is, keep the y where it is, keep the z where it is, but I just want to collapse the numbers themselves. So if there's any arithmetic
Oh.
that needs to be done, so 2 and 3 will get added and they'll become the coefficient of the sum will become the coefficient of x, but x's and y's will not start moving things around or will not
Mm.
start moving around.
Mhm. All right. So, yeah, so we can see our different options here. And notice that normalize order, reorder commutative operands into canonical form without simplifying values. And that's what we'll want for our second one is reordering those additions to a standard order. But for the first one, we just want, we can use just simplify by itself. So if we have simplify with no value, that's the same as saying simplify is full. And so now we see that that simplifies it down to 8x plus 7. And as we were noting, if we instead change the value of simplify to normalize order, now we don't have that kind of combining terms, but we have the x's coming before the constants. So in that standard order without simplification. All right, so for the next one, looking at how does it simplify x minus 1 times x minus 1? Well, we can take a look at that. So simplify and x minus 1, x minus 1. So we see we get x minus 1 squared. So it combine those there. And what do you change if you want it to expand instead?
Wouldn't you just use expand instead of simplify?
Yep, exactly. So just change that to expand. And so now we have x squared minus 2x plus 1. So now this is something that will come up later when we're looking at references. Let's suppose we're working with x minus 1 times x minus 1, and we don't want to just think about this as a math expression. We want to think about it as a function. And so we want to be able to do things like evaluate this function. Did anyone figure out how to get Donut to think of this as a function as opposed to an expression?
You wrap
Looks
it
like
in
you
a
have to use
function
the,
tag.
yeah.
Mhm. Yeah, so there's another tag that we'll use for this, which is function. So this is one that you would have had to poke around the documentation to find. And so we've got function x minus 1, x minus 1. And so it doesn't look too different there, but later on this will allow us to work with it like a function, evaluate it, and then kind of just plop it into a graph and graph the function. So that's a good one to be aware of, and will come up more later once we're looking at references. So the last thing here when we're looking at number pi, and I'll make another one here for math pi. So that's what we see there. How would you describe this difference? Yeah, so Clark wrote in the chat symbolic versus floating point. So when we're looking at it as a math, we're seeing like the symbol pi, we're not, representing it as a decimal approximation. When we have a number, that'll be like a floating point approximation or a decimal number. And so when we want things to be kind of perfectly precise, exact values, no approximations for pi, we'd want to use math, and so that we're sticking to the symbol pi. If we're using numbers, that'll be working with decimals. And it's important to note here that this is displaying two decimals, but it is actually storing it to a higher precision. So it's uh, a closer approximation than two decimals, and you can adjust the decimals displayed. Anurag just posted a link to kind of how close you can get to pi.
Oh,
If we
that's a giant waste of time. It's an activity I made. Just that was a it was my version of a useless machine. You have to keep dragging a slider so that you get very very close to pi, and you get silly messages at the bottom. But yeah, that's not a
uh,
documentation thing. But if you're bored during one of the breaks, you can see how close you can get to pi.
Yeah, and so then if we want to change our how many digits are displayed here, we can use the attribute display digits, and this is the number of significant digits displayed here. So we have three significant digits. So we've got three, and then the two places after the decimal. So we could change this to 10, say, if we wanted more there. But again, it's stored with more precision. This is just adjusting what's displayed. All right. Other
Is there a
questions?
difference? But yeah, sorry.
Mhm.
Is there a difference between display digits and display decimals?
I don't think I've used display.
Yeah, that
So
just
display digits is significant digits, and decimals would be after the decimal point.
Okay.
Mhm.
Okay. Cool.
I have a quick question. The maybe a quick question, I hope. Back to the x minus one. I actually read it wrong and wrote x minus one times x plus one. So I named it diff square. And then I had originally just used that in the math tag, but then I set it up as a function and and ran it, and it doesn't, the math expand doesn't seem to work when it's a function. Is that like, does it treat functions differently than expressions, I guess is what I'm asking.
So are you saying you did this?
No, I just said function name and then called it whatever. And then um and then the math expand, I put in just F.
So
so
like that?
Uh-huh. No, well, let's see. Was it math? It was math expand. Oh, you know what?
Didn't use the dollar
I put a
sign.
capital S. Yeah, it was slightly different.
Hmm.
That was the problem.
Uh,
The title. So annoying.
Case sensitivity. It's can be annoying. Other questions or issues at this point? So that was a kind of quick example of what we're about to talk about, which is references, what I just did with that dollar sign there. And so that's making a reference to this function. And so instead of kind of copying over this function here, I'm having it refer to this so that it's using this function in that math here. So we can do that with functions. Let's look at something a bit simpler here and just start off with a math. And we'll go back to our x minus 1, x minus 1. So if I name this uh, A, now I'll make this a paragraph so things are separated out. I can refer to A using that $sign. So I'm using the name that I gave to this component, and the $sign is what's telling it that I'm referencing it. I'm not just typing a letter A. So we'll see we have the original up here, and then because I've got the reference to it, I'm displaying it again here. So something that this allows me to do is get properties of objects. So the properties are going to be, well, properties of them. So some of the things that we can get as properties are things that we've looked at before, like the simplify level. Um, so this has no simplification applied to it. Um, we can do our display digits and see that our display digits for this math object is 3. If I were to change the display digits to be 10, now we'd get that changed value 10 there. So, kind of not terribly interesting for these things that really you're just using to control the behavior of the objects, and it's not so likely that you'd want to be able to access those values. But this ends up being really useful for other things, like let's say we're working with a graph, which is something you'll be doing tomorrow. And so we have a point named P, and it's got 2 coordinates, and we want to get its x coordinate. So I can reference the point P with $P, and then use dot x to get its x coordinate. So once I update there, we see our point 5, 2, and then the x coordinate 5. So then, and for example, I could use this to say, have the student enter a value and check a condition on that value. So let's go back to using a math here. And I'm going to make this 5 now. And let's say I want to be able to, actually, let's get a math input first here. So we're going to get input from a student. So we'll say math input, label, enter a number, and we'll name this A. So I can see what value the student is entering with the reference here. So have the prompt to enter a number. I put in 5, since apparently that's the only number I can think of right now. And we see that 5 displayed here. So let's suppose we want to have them enter a positive number. So I want to add in some checking to see that they've actually done that. So now I can use an answer and do award win. So instead of awarding for a specific value, now I'm awarding credit based off of a condition. So references are super useful for constructing those conditions. So this sequence of nested tags is really common for this. Answer, award, win, and then we write a true, false condition in here. We want to just check that the number that the student entered is positive. So we can just check that A is greater than 0. And I'll move this kind of back up here so we can see their value. All right, so when I put in 5, we can see that I entered 5, and then I can check my work, see that that's correct. If I change it so I'm entering 9 instead, that's also correct. If I'm entering in -3, not correct. 0, not correct. So now we can ask kind of more complicated things of students and then build the criteria for awarding credit based off of conditions on their input by using references. So the kind of key setup here is using an input that is given a name and then using a reference to that input when we're building that condition.
Before you move on to
Yep.
something else,
Mhm.
Melissa, do you mind sharing what you had earlier? If you're done with this part, can you undo your way back to what you had previously and share that in the chat? Once you're done with what you're talking about.
I think that was wrapping up that point. So where do you want me to go back to?
Never mind. Jane's got it.
Okay. All right. I think I jumped ahead of what I actually wanted to talk about. I get excited about the answer checking. Um, Another thing that we looked at was functions. And so something cool with functions. So you've got x minus 1, x minus 1. This is just amazing to me. So we've got our named function here. I put in too many paragraph stuff. So we can reference our function. We can also get the minima of our function using the minima property. So that will give us the minimum of the function at 1, 0. And that's just incredible to me. It's just like you get that for free. But another important thing to know, okay, wait, I'm going to pause here, do an exercise to get some practice with this, and then we can talk a little bit more about functions. So next task here. All right, switch over. So create 2 math objects, name them A and B, have Donut calculate their difference, and see what happens if you forget a dollar sign, which is the certainly one of the most common mistakes I make when writing donut things. Perhaps the most common mistake that anyone makes. And so can see what happens when inevitably you make this error. Oh yeah, I forgot to say a time. Should we say like 3 more minutes for this?
Um, Melissa, I just had a
Mhm.
question going back to the dollars F dot minima that it said it gave you a minimum because I just tried it and it didn't really give me anything. Was there some thing to indicate like a domain? Because I don't see how you'd get a minimum. Or was it looking on all the reels? I don't know. I didn't really get
So
the
it's going to be
name.
local minima.
Okay.
Um,
Because it just gave me back the name of the function. So probably I did something not correct to define it, but
can you copy paste your code in the chat?
sure.
That certainly looks fine.
So it gave me x minus one, and then x minus one as a second output. Or maybe it gave me, wait, I might have that written down twice. So it gave me no output, but was it supposed to give me an output? Oh, actually it did. Now it did. It gave me 1 comma 0 as the
Okay.
order pair. Okay.
Yep, so that's good.
All right. All right. Well, I'll wait to see what to do with this difference because is this a function of two variables? Um, yeah. I'll just watch, see what everyone else does.
Yep. Mhm.
So I had something interesting happen.
Mhm.
Let me actually paste what I had typed in into the chat.
right, let's see.
Oh, that, oh, I have an extra P tag there.
Ah, that is interesting that the simplify
They reordered.
it
Yeah.
messed with your equation.
And not in the way I would have expected.
Uh-huh.
So this
Yeah.
is like what Anurag was describing. If you do, like I do a lot of pre-calculus content, and so I use numbers preserved order very frequently so that it doesn't sort of shift things around on you.
Mhm. Yeah, so let's use this as our starting point here. So we've got our named components, named math components. We've got A there and B here. So A is 7 and B is 11. So for subtracting them, that's with the dollar sign A minus the dollar sign B. If we want to just isolate that and kind of not worry about the extra formatting, we can do that with just having the dollar A minus dollar B in the math there, and then see that we get -4. If we leave off the simplify, then we just see the difference displayed, kind of just filling in those values as we wrote it. So since we want that computation, we probably do want the simplify there. If we want to add in, like Clark was originally going for with the having the A and A minus B there displayed there, so we're showing what it is. One way to kind of get around that rearranging issue without using the attributes would be to kind of separately write A minus B equals, and then have the math simplify only having the dollar A minus dollar B. So then kind of this first part is just display math, and then the -4 is being computed there. So that would be one workaround there. And then if we forget a dollar sign, so I forget that dollar sign on the A there, then we see now we just have A minus 11. So it has no reason to think that I mean this math thing named A. It thinks I just mean the letter A, and so that's what it's putting there. So, uh, forgetting the dollar signs, if you're just seeing the names of components popping up, that's probably what's going on there. Any questions, issues, different ways people approach this?
I tried to make a function of two variables and it didn't work. F of xy equals x minus y. Is there a way to indicate? Yeah, I'm not sure if that even makes sense, but could we
Virginia,
use?
does it support functions of two variables or just one?
Can you have to use variables as your
Ah,
attribute and then include them as a list? So that's, I'm not sure
so it's
if that
something
was the
like this,
format.
right?
I think so. Yeah.
Mhm.
Do you want to go ahead and paste what you did in the chat?
No, it's really no.
Okay. Um, yeah.
Um, well, I mean, I could, but it doesn't. I'd rather try and get it to work first.
Okay. Sure.
If you have a single variable function and you just don't want to use x at all times, then you can, when you're defining the function, you can say variable equals t, for instance. But
Mhm.
if you have a multivariable function, then variable must be pluralized, and then you can add a comma, not a comma, a space separated list of whatever your independent variables are.
So Spencer wrote, should I read math, simplify, numbers preserve order as simplify the numbers, but also preserve the order that I've written? I think so.
Yes, but there's something weird that happens, which I guess I just don't run into very often, but I noticed Dwayne mentioned this in the last workshop for this particular topic, and that is I think if your numerical values are separate, it doesn't combine them. Like they have to be adjacent. Is that correct, Anurag? I'll test it real quick. So if you have that weird thing that we were looking at earlier where you had integer, variable, I don't think it um, does quite what you want. I don't know if that answers the question completely. Um, yeah, let me just get back to you about that in 2 minutes because I always thought that it did exactly that.
All right, and then Cameron has uh, this example here. Um,
That's weird. It's not doing the math correctly on my end,
oh,
but
so I'm not sure
yeah,
about the double dollar sign with a math here. So the only use of the double dollar
yeah.
sign I know is for function evaluation, and so I'm not sure what this does with
Okay.
the math if yeah. So it might be that it's just kind of breaking and not having anything there.
Yeah.
And here it seems to be, yeah, just filling it in as though it were just dollar sign A. Um,
Yeah. On mine, maybe I just need to like refresh the page or something. It's putting like a blank like underscore and then minus parentheses x squared plus 2x plus 5.
yeah, that's what I would expect that, it doesn't know what to do with this.
Actually, I think the issue there
Yeah.
is that you've reused a name
Oh,
because I had that
okay.
happen.
Okay. Okay. Cool.
So that answers a question from yesterday too, I think about, or actually I think it was Matthew asked earlier about reusing uh, names and labels.
Mm.
Mm,
Yeah, so that's a good point here. So I'm gonna delete this for now, but as I'm working on things, often I'll, copy paste something because I want to do something similar, and so make some edits. And so then I end up using the same names repeated there, and then we run into issues because there's ambiguity here in what it's referring to. So it'll do its best to resolve the ambiguity, but here, because they're kind of within the same unit here, it has kind of no reason to prioritize one or the other. And we can see this warning here that we've got the multiple reference found for those references. One way that we could fix this is by wrapping these in some sort of block so that there's
Oh,
a clear separation. And so if they're in different sections, then it's smart about knowing which one it should pick up on. And this A will get the A that's basically closest to it in scope, and same down here. So they'll get the values that we want there. And so then we can reuse our names with wild abandon as long as we're breaking things up so that it knows what it should be looking at.
I'm curious what you guys think would happen if Melissa changed the name in line 9 and 10 to C and D, but kept 12 intact. So, what do you think should or would happen here?
I think it's going to use the A and B previously defined.
Spencer predicted blanks in the chat.
I'd go for blanks if it did it right.
So it is going to use the previous A and B. So this can be a nice thing if you really do want it to use the old ones, or it can be a not nice thing if you want it to be using the new ones. So it will pull the A's and B's from the closest scope that it can find. So it's not as kind of rigid as like programming languages. So there's some kind of scoping, but it's a little bit more loosey-goosey than in programming stuff. Um, so Spencer asks, so it only scopes if it is forced to do so to resolve ambiguity. And yeah, that's exactly it.
Are sections and subsections the like things you use to create that scope, or are there other things?
There are other things. I think group, I think, is one. Is that right?
It basically can be any parent component. So
Yeah.
problems, exercises,
Mhm.
divs, graphs, yeah, it just goes to its parent element.
Mhm.
Um, is there a clear function for a variable? Can you clear it? Or it doesn't work that way?
There's no way to do that. It's actually if you it takes a while, but it's helpful to sort of train your brain out of thinking of these things that you're giving names to as variables.
Okay.
So and that helps a lot because a lot of times it feels like you can do so much with it. It feels like you have a programming language in front of you, but that's not really how the tool works. So
Mhm.
so you can't like really loop or redefine things. They're sort of like stand-in things to get somewhat of that behavior, but um, it's more of just like you're semantically defining content.
Mhm. Anurag posted Dwayne's classic quote, "Donut is not a programming language." All right. Any more questions, thoughts? Should we look at functions a little bit more here? All right. So let's take a look at functions a bit more here to see that function evaluation. So we'll make a function, give it a name, because we are not clever. It's going to be f here, and we'll just use x squared as a classic function. So we can refer to the function with our $f. And we've got it displayed twice, once for when we're defining it, and then once for when we're referring to it. Now, let's suppose we want to evaluate our function at a point. So if we have like this, that might be the most obvious thing, but it's not that clever about it. It just thinks we've got the reference to the function followed by 3. So we've got a special syntax to distinguish between that and say, no, we're evaluating the function, and that's the double, not that, the double dollar sign. So double dollar sign will evaluate the function at the input that we give here. So now we see that we get that evaluated to 9. And we can use that in combination with other references. So let's suppose we have a number, and we'll make that number 3, and let's call that A. So if we want to evaluate f at A, what do you think I would put in here? Yep, $A. So then we get the function evaluated at that value A. So you can imagine we can do things like having a student give a function as an input, and evaluating that function at different points, or having the student give a number as an input, evaluating a function at that number. And so having some different options to work with there. Any questions about this before we do another task here?
Just for fun, I think you should put it in a graph because
Okay. All right, and we'll refer to our function
I have strict instructions
here.
to keep things on track. Do not talk about graphs. Never mind,
You're
too
not in
late.
charge, Anurag.
But the cool thing also is what happens if you do f dot. Uh, so you can also graph properties, which is exciting.
What
I'm
did you
gonna
want
be
me
in
to do,
so much
Virginia?
trouble.
So do a space, then
Okay.
just do f dot mem. Oh no, do both. Do both.
Oh, okay. Yeah. Woohoo!
It's just cool, you know?
Yeah.
If you come back tomorrow, we will only be talking about graphs then, and nothing else, which is supposed to be discussed on Thursday, and
It's
today is
related to
Wednesday.
properties and references.
It's on topic. All right. So, yeah, so we've got another task for you at this point. So we'll go to that. Um, create two numbers, a and b. Use them to write an equation of the form x plus a equals b. Ask the student to solve that equation and create an answer blank to validate that student's answer. And then change this so that A and B are math inputs rather than numbers that you're providing ahead of time. So essentially, you're going to make this so that the student is building their own equation and then solving it. So I'll put that in the chat as well. And we'll give you 5-ish minutes to work on that. All right. So how should we get started for this? All right, so Spencer's skipping ahead to three. I'm going to have us start off with where we're hard coding our numbers in before changing this to math inputs. But that is a great start for three. All right, thank you, Matthew. So we've got our number name is A, and uh, who wants to pick a number?
65.
All right, 65 it is. So we've got A, and similarly, we're going to have B here. And so what's a great number for B?
42.
42. Great choice. All right, so we've got our numbers 65 and 42. So we want to now ask a student to solve the equation x plus a equals b. So how should I set that up?
Well, from yesterday, you would need to make an answer with a label around it to make it friendly to blind, to make it user friendly.
Yep, great.
And
So yeah, we'll use an answer and let's use the answer labeled snippet here. So I'll start typing answer, go down one and select that. And then for our label, you can just say solve. And then to write the equation that we want to solve, what would make sense to use for a kind of tag here?
dollars $A plus dollars $B.
So dollars A plus dollars B, or we have X plus that. If I want to display this nicely, what kind of tag would I want to put that inside of?
The M tab.
Yeah, so we'd want to use the M tag here. We just want to display it. We don't need to do any computation with it. So we can just use our plain old M tag here and say solve x plus, and then fill in with the value of the number A equals fill in with the value of B. So let's make this a new paragraph here. And now can see I don't have any actual answer put in there yet, so there's no answer blank, but we can see the prompt at least. And if we make our classic mistakes of forgetting the dollar sign, we would just see solve x plus a equals b. All right, so we've got our label set up. What would the correct answer be here? Yeah, so we can compute that from our numbers b and a. And doing the algebra ourselves, we can realize that no matter what a and b are, the right answer would be b minus a. So now we can do that arithmetic and say, oh no, I have to do arithmetic. All right, 23,
I can
hopefully.
help. Oh,
Yes,
it's
nailed it.
42 minus 65.
Huh?
It's 42 minus 65.
Yeah.
I can't do arithmetic, so I just typed in 42 minus 65. I wonder if
Oh,
I get it
right,
correct.
right. Great point. So, if we want to, I don't know, do we want to force our students to do arithmetic or not? What do you think? Anurag does. Any ideas of how uh, we can take care of that? This was from yesterday, right?
Symbolic expression.
Symbolic.
Yeah, symbolic equality. Yeah, so now, oh, this is that one. Anurag trapped me. All right,
No, no,
save me,
no.
Anurag.
It's not a trap. Um,
It's an
what?
opportunity or
It's an
something.
opportunity to learn. It's an adventure in the knowledge yard. So, what do you guys think is happening?
Because she wrote B minus A, it has to be in the form B minus A.
So if I do, nailed it.
So now the unintended task is how do you get it to grade exactly negative 23 correct and nothing equivalent to it? What would you modify?
Can you simplify it? Simplify dollars B minus dollars A.
That is so smart. Okay, we'll try the bad way first. So far, so good. Woohoo! Nice. All right. So, something to note here is that we've still got that 65 and 42 floating up here from when we defined the numbers. Yes, that was an excellent trap, Anurag. Good job, or opportunity, or whatever you want to call it. Um, so yeah, you might not want to, or probably don't want to have the 65 and 42 floating up there. So a way that you can hide them, well, there are a couple of ways. There's a hide attribute, but that's not so great if you've got a whole bunch of stuff that you want to hide. And so for this, we can wrap them in a setup tag. And so this is the idea is that you put things that you're using to set up the activity, like numbers that you're using elsewhere, but you don't want displayed. You put them in the setup tag, and then they're defined so that you can reference them, but they're not displayed. And so you only get what you want actually displayed showing up there. So that can be a nice thing to make use of that setup tag to keep things nice and neat. Any questions, thoughts, different approaches to this?
Only thing I'll mention here is something I've learned from Virginia over time. And I don't know that it's as strong as blanket statement as she would make, but I prefer to put all my computations within the setup tag. and then refer to them later on in the activity. And maybe Virginia can explain why this is a good idea. But that way, all the computations are towards the top of the page where my setup tag lives, or setup block lives. And then I just have to modify the quote unquote formula in one place and then just keep referencing it later. So, had we named the simplification step in or line 9, then we could have just said the answer is diff, if that were the name. And then if you need to change the formula for finding the diff to a sum, you do it in the setup component. Virginia, is there a reason for why that's a good practice to have based on your
Um,
experience?
Yeah, I think it depends on the kind of activity you're building. For me, I was building hundreds and hundreds of problems where it was just like sort of easier to sort of have a workbench where I thought through what I was going to achieve at first, and then troubleshooting became easier because everything was in that place. Um, so sort of workflow, getting everything set up and having one place to go find it. But if you're writing a long, sort of meandering activity that evolves, um, maybe it's like an hour-long in-class activity, which lots of moving parts. So in those cases, it's very convenient maybe to have something right by one of your examples where you're doing a setup with new parameters just for that example, and it's local to that. So it just kind of depends on what you're doing, I think.
So you can have multiple setups in one document then?
Yes, and
Okay.
you can have them anywhere you want. For some reason, now Donut gets mad at you when you put it in a solution, which I do all the time. So I just ignore that warning. I don't know why it happens. But you can even put it inside a graph, and it'll just hide whatever calculations you're doing inside your graph.
I just remembered another mind bending thing, if you'll allow me the detour. Melissa, can you create a setup tag underneath everything? So in line 12 or something? And then put line 9 inside of it and give it a name? So notice that, well, C is defined in line 14. What would happen if we replace line 9 with $C?
Hmm. Thank you, Spencer.
Yes, but
So,
don't do that because
no, 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 no,
then
no. This is wonderful.
if someone is checking your work, they're like, "Where is C?" So again,
It's a
workflow.
bad way of doing things for readability, but oftentimes I will write something out and then it's not working. I end up creating or naming something that I go back and use somewhere prior, and all of a sudden everything starts working. And yes, I should probably be doing some cleaning, but my wife says I don't do that anyways, so maybe the crime fits. But yeah, Donut is not a programming language, which is why it doesn't matter where things get defined. So you can
Mhm.
define everything at the end of the end of the activity or at the end of the document, and then refer to it prior. There's no sense of linear timescale, which
Mhm.
when I saw it for the first time was jarring, but also beautiful.
Mhm. Makes it so some really complex things work really nicely. All right. So we'll get rid of this nonsense. Um, all right. And so then the last task was changing this so that the numbers A and B are gotten as input rather than kind of defining these as just 65 and 42. So was it what started me off there? Uh, Spencer. All right. So Spencer had suggested, uh, I'm just going to copy this. We have our math input with the name A, the label enter a number, And we can duplicate that for our number B, enter another number, or actually, let's say, yeah, whatever. All right, so we've got enter a number, and to be uncreative, we can put in 42. Oh, I switched the order, so it is going to be different. 65 and solve the equation that we just invented, and the solution is now 23. So the change that we made here was just instead of having A and B be numbers, getting those as math inputs. Each of those is has a name and then the label, which is what's prompting the student, telling them what they should be entering in there. And I removed the setup tag since now this is something that we definitely want displayed. Otherwise, the students wouldn't be able to put anything in there. Questions or other thoughts here? All right, so I think we're going to take a long overdue break. Um, how long do you think, Anurag?
Negative 10 minutes.
All right, so we're 10
Shall
minutes
we?
into the next half.
Let's reconvene 50 minutes past the hour. 6 minutes for a quick stretch.
What?
Six
15
minutes.
minutes past the hour? Half an
50,
hour?
50 past the 10 minutes to the next hour.
Oh, okay. I see. Yep.
4:50 p.m. Eastern.
Is that
All
a
right.
6 minute break then? Six
Yes,
minutes?
Yes.
6 minutes.
Five and a half now.
Let's just take a 10-minute break, Anurag. Come on now.
6 minutes. You get what you
Precise.
get and you don't complain. Or no, that's not the saying. You get what you get and you don't get upset. I knew
Well,
I
we'll see
butchered
when
it.
Virginia starts.
Hmm. Yep.
Well, I have a quick show and tell, so I will start at 4:50.
Okay.
Looks like everyone went with Virginia's plan.
Victory!
The resistance wins somehow.
Oh yeah, I should probably actually go to the bathroom.
I don't like this whole being the adult in the room. I don't know how I got saddled with this. Virginia and Melissa are way better suited to
No, you are the
being
grumpy narwhal.
taskmasters. Well, I am grumpier of the three of us for sure, but I guess we'll wait for Melissa. I have a very short show and tell of something else that you can do with Donut that's not in the standard vein of things that you might see in your favorite platform or your most hated platform. And if you're curious and you want to play with it, here's the link.
I have a quick question.
Sure.
Um, is there any convenient way to like output this as like a PDF that you can print? So you could like have a set of handouts for class and then say, okay, here's a link where you can try things with different numbers after class.
Define convenient.
Um, maybe like a little button that you can press where it says, okay, here's a, compiling to PDF kind of a thing.
I feel like I'm in so much
Or
trouble. Things can't get worse. Um, don't follow anything that I'm doing.
I see nothing.
You see nothing. Nothing is happening here. So this activity will probably not make sense to be printed, and I don't know that it even will.
Yeah, I mean, I'm
Uh,
expecting a lot of these to not necessarily be something that I'd want to have printed, but I'm just thinking about like other people maybe using this, asking the question.
okay, so I did
Okay.
something, and it's buried. It's not even a feature. It's a demo that maybe you can find if you know exactly where to look. But if you go into the documentation, in the pipeline is a way for Donut things to be converted to pretext things. There's a subset superset relationship, and I don't know which way things go depending on the day of the week. Um,
Mhm.
there are things that I certainly think ought to be printed, but then one of the strengths and the benefits of Donut is the interactivity that you can play, and I think a lot of that comes out tomorrow when we start talking about graphs. It's very, very difficult to come up with a reasonable printed approximation of, hey, move this slider and see what happens. But I don't know how you do that on paper.
Yeah.
That's not to say that people don't already have just their course notes, like things that you would have in a LaTeX environment and then create a PDF and put on your LMS somewhere. I have seen, I should make a note. I'll find it and then I'll share it for tomorrow during show and tell. I don't know the gentleman, so maybe I have to ask for permission first. But this person
Mhm.
has their course notes, or at least some version of them, on Donut. Those could conceivably be converted to pretext, and notice that I didn't do any of this. There are these fancy buttons that you press in order, and you hope for the
Mhm.
world to not blow up, and eventually this comes out. Now, this can be printed by way of pretext.
Cool.
Is it convenient? Sure, it took me 10 seconds to bring it up, but you
Yeah.
kind of have to think about what you would want printed and then kind of work backwards and say, if it's an activity, I don't know that I
Yeah.
want to print an activity that requires interaction.
Yeah. But yeah, I guess I'm thinking of it in part like maybe even if it's just I don't know, some kind of like skeleton notes that you can fill out, and then you can go online, and then there's skeleton notes plus some interactive exercises also.
Give me until
Maybe,
tomorrow. I'll find the document I'm
yeah.
thinking of, and then I can have it shared. I don't want to waste your time trying to find it,
Oh yeah,
especially
no,
since I
no,
don't remember the
it's
gentleman's name. But I'll show you what I'm thinking of.
yeah,
Okay,
cool.
now
Thank
that I
you.
have gone on another detour that Dwayne will probably chastise me for, here's an activity that I use with my students. It's only got 5 problems. And I tell my students if you work in groups of 4, there's only one laptop permitted. So this speaks to maybe Spencer's notion the first day of a lot of us fight with an appropriate use of technology in our classrooms. One way that I battle that is each group can only have one laptop screen per group. And I am in a privileged environment where there's one classroom per campus that's an active learning studio. So all the other classes are regular, 36 students facing the wall or facing the whiteboard, but there's one room that's set up as an active learning studio where we have a giant like 90-inch screen. So the one student takes an HDMI cable, plugs it in with an adapter into their laptop. That way all 4 students are seeing one screen. I also see that screen. So if they're doing something they're not supposed to, they get a little tap on the shoulder with a reminder to stay on task. Uh, my class is set up to be 75 minutes and it meets 3 days a week. I tell them once the entire group is done, you can leave, which never happens, but hope springs eternal. So there are mechanisms and levers and knobs that you can turn and pull to make it so that you're incentivizing students to stay on task without making it seem draconian, even though it is fairly draconian behind the scenes. So I tell my students, you have 5 questions. Once you're done with all 5, you can leave and you can answer my questions to my satisfaction. So here, the standard thing that they've seen since middle school is a worksheet that has 15 linear equations in it. You solve them, and ugh, it's boring. Here, they have to come up with numbers that create an equation that must have a solution of x equals 2. So if they're completely brute forcing this, they're just trying random numbers, solving that equation, and saying, shoot, 2 is not the solution to this equation. Or they get lucky. Either way, at the very least, they're solving more problems than I'm assigning. I have assigned them 5 questions. If they deeply understand what it means for something to be a solution, they only have to solve 5 problems. No one does, at least at this stage of the semester. So this one they can solve fairly quickly. Numbers are fairly easy to guess. Then there's a similar skeletal structure. This is a plus, this is a minus. Now, they're not allowed to reuse any of the numbers that they've used in the past. So by problem 3, things get gummed up really quickly, and that's when students have to recognize and wrestle with this idea that there are numbers that are not integers or numbers that are larger than 10 or less than 0. So this is where, hey, we talked about integers at the start of the course. Let's, genuinely use them. So even though it's only 5 questions, this one just they absolutely hate. Um, but yeah, you have the ability to do something like this. Now, I encourage you to think about how you would even do this on paper. So, number one, the students have no immediate feedback on whether the equation that they've come up with is correct or not, unless they raise their hand, and I have to now come in and, you know, verify their solution. Or worse, they assume that their incorrect work is correct, and they just keep barging ahead without getting a little, you know, buzz under their chairs that says, that's not quite right, or that's not quite right yet. So here, students can pace themselves. They don't have to wait for me. They don't have to move at the pace of everyone else, but invariably, the stronger groups in class might finish with perhaps 7 or 8 minutes to spare. Uh, Students who don't stay on task, for them it becomes homework, and no one wants to do this by themselves. So fairly quickly, they realize that, hey, if we're allowed to leave early, might as well take advantage of that. And Melissa showing her true colors as a CS person. All right, now Virginia will share how to do even more powerful things.
Yes. So get ready to have your brain squashed because I'm about to throw like a ton of stuff at you, hopefully get done in time. Um, so I'm gonna go ahead and start by just sharing my screen, and then I'll give you the document in just a few moments that we're gonna work through together. Okay. So I'll just make this bigger. And does that look okay for everyone? All right. So we've been doing everything with explicitly defined numbers and parameters and variables. But the power of Donut is when you start adding parameters that can vary into the mix. And one of the nice things about it is that as soon as you do that, Donut automatically creates different versions of your activity, which are called variants. So one of the most fundamental way to do that is to create what is called a select. And we're always going to use, name these things because we're going to be using them later on in equations and other places in the document. So a select can be really, really complicated because you can give it options which have families of things which are grouped together, or you can just give it a list of numbers or a list of letters or a list of words, and it'll just grab one from your list. So it's a space separated list. And so if you don't have a structure, this is what you want to use. So I'm just going to pick some random some numbers here, and then go ahead and click update. And that's what renders. So A is selected as 6. And as you can see, as soon as I did that, this widget popped up here. And what this is a way for you to browse through the different possible options or different variants of your activity that were just automatically generated. As soon as you dump this select tag into your document, these happen. And I have 5 of them because I defined 5 different values, and you can scroll through them or you can select individual ones. Okay, so that's select, and let's do select prime numbers. I'm going to call this B. And for prime numbers, you can give it a range or you can go with the default. So in a lot of Donut components, you can underspecify them and Donut will assume something for you. So let's see what happens if I don't specify anything else and I just call it B. So it's selected 61. So if you're curious, you can go here. And I thought it had more, but the reference page will tell you. Defaults. Okay, so it defaults to like 1 to 100, basically 2 to 97. So let's say I wanted to restrict that. Maybe I want to go up to 50. So you can define your range. Your range endpoints don't have to be prime. And that's how you can like tweak the parameters range. Another one that I use more than select prime numbers, you use it basically everything you do is select from sequence. And this can be a sequence of numbers or letters. I'm gonna call this C. 1, 2, what if I decide to do 20? Okay, so it's selected 17, and now you can see I have a whole lot more variance. And I believe defaults to 100? I don't know. Thinks that's what it is. And you can ask for more. I never have done that before, but I know there's a way to do that. So alternatively, you can also design an activity and think, okay, I wanna build all this variation into it, and then maybe you using it in a different context and you want to assign it to some students who are doing group work and they only see one thing. So you can also in the settings for your assignment say just pick one. So that's also possible. So now that we've kind of like started, we're setting something up. What I tend to do is I get annoyed with just lists of numbers, and I know I'm going to be defining a bunch of things. So for clarity, I'm going to put things in a setup like we just showed you. And then because again, I just have this like really procedural way of thinking about things, I need to see everything that I just defined. I mean, I don't want to see it, but I want to see it. I don't want to see it the way this gobbledygook spits it out. So I always create, and this is totally optional, this is just how I like to set things up, what I call like a little testing block, and actually comment it so that people who are looking at my source can see this is just me playing around with stuff, making sure everything works the way I wanted it to work. And I separate it out by p tag, so it's very easy to read, and I define it. So I'm just going to go ahead and say, tell me what A is. And then here is a trick that Dwayne told me, which just saves me so much time, is all you have to do is put your cursor on this line and you just hit Control C, Control V, and it just automatically copies over the line. So you don't have to like select it all and then go drop down to the next line. You just Control C, Control V. So you can end up doing this really quickly. And then I comment this out. So this is just saying, hey, heads up, everything in here is not really important. It's just for this phase of the game, I want to see what's going on really clearly. So that's just kind of my practice. And then at the end, when I'm done with everything, all I have to do is get in between this and select everything and comment it out. So, okay, so those are 3 different types of selects. And it's time for me to share this with you. Updated for, oh, it is updated. And then we're going to do a couple tasks. So I'm going to try and keep these like short little descriptions of what we can do, and then we'll do more short tasks. Here's that. And then
Virginia, what was your hotkey to duplicate a line?
oh, just put your cursor inside that line, and as you can see, the whole line is like highlighted in gray. Then you do Control C, Control V. So you don't have to move anything or highlight anything.
Control C, Control D.
Control V. You're just copy pasting, but because the editor's smart, it knows I just want to copy that whole line of code.
Nice.
Yeah. Okay, so what I would like to do now is we have some tasks. And this first one I want to do that one. Oh, I'm going to show you one more thing, and then I'm going to have you do 1 and 2. So another thing that you can do is you can do a select from sequence. I call this D, and you can do a step size. So it doesn't have to be an integer value. You can do step up high, you know. So I'm going to do a step size of 0.5. And then I want to see what that just turned out to be. So what got selected? Just 1. And you could see where are my 0.5s? Ah, there we go. Took me a second to get to one that had a decimal value. So go ahead and do tasks 1 and 2. And then when you're done, if you want to, you can go ahead and in the code, you can comment out. These are these parts right here. So the numbers are coming from the fact that I have a list of parts. So you can just comment that out when you're done if you want. So we'll just take like 2 minutes to do that because they're pretty quick.
Sorry, I'm just trying to get going on this question. Is this about some of the numbers look like plain text while others look like rendered math? I only have 2 numbers and they both look like rendered math, so I'm not quite sure what is
Yeah.
going on here.
I mean, it bothers some people a lot. And to be honest, a lot of times I don't even notice. But that's because this default value here is actually that's what looks like plain text. And I'll show you by just doing.
I can only see 2 numbers. Is that correct?
Oh, you know what? I mean, if you are.
I opened your
Oh,
file.
you added it too. So you guys might need, you know what, let me just send it again. Or you could go ahead and I don't know what's easiest to copy what I have or to re-copy it.
If you paste it in the chat.
Oh yeah, that works. Okay.
If it's the same file you're working on, every time you update, it also gets updated on the user's end.
I saved it to
No,
my own
because
space.
they wouldn't be working on that version. They'd probably
Okay.
be taking it and then copying it in. So yeah.
Should I just start on number 2 since I can't do number 1? Because I
I
didn't
think
see any
you're
pasting.
gonna want all of them. So
How do I get it again? Then I start over?
if you click the link again, it'll give you the most up-to-date version, but then you'll just have to recopy it or add to your folder.
Okay.
That makes sense. Yeah.
Yes, I'm just saving it.
All right, it'll take about 1 more minute.
Oh, I see. Some of the, yeah, okay. Well, the math tags are messed up.
Mhm. So one thing that was confusing to me for a while is that like a number object and a math object in Donut is sort of different under the hood. So Donut treats them differently. And for some reason, numbers are just rendered as plain text, whereas math, something defined with a math is rendered in this prettier font. So it can be a little bit jarring if you have like the left-hand side of your equation looks one way and the right-hand side looks a different way. So it's handy to sort of get in the habit of using M tags, and then you can always nest things inside as long as they're not components that take an input from the student. So if you have an answer tag or a math input, you can't actually nest those inside. That's so yeah, to do part 1, all you need to do is surround your reference in an M tag, or you can surround, C is also a number, so you can surround the whole equation in an M tag. All right, so we have taken care of number one. Comment this one out. And does anybody want to share what they did for this second part, which is now part one?
The numbers just changed, right? Am I doing a fruit?
Oh, yes, they did. They did because I commented it out. So now we're talking about this one.
Okay.
So you don't
All
have to
right.
work on this part yet.
All right. That was tricky. Okay. I think I did that. I mean, that you just changed the 0.5 to a point to a different step size, right?
Exactly. Yeah.
Yeah.
So it's just practice using that attribute, step size attribute, which I think is really handy sometimes.
Sure.
Okay, so that one it's pretty straightforward. Let's go ahead and I'm gonna share another way you can use select, and we'll do a couple more. Okay, so talk about that. So another thing you can do to create variation in your activity is you can actually choose what variables, vary the variable letters that are being displayed to the student. So instead of just X, you can select from a list of nice variable names that you like. So I usually use just a select for this because there's only a couple letters that I like. But I'm going to call it bar. And then when I want to insert whatever random variable gets chosen, instead I'll type bar. So I like X, I like Y, R, S, T. So this is a space separated list. So I define it there. I'm going to use my testing block here and see what it looks like. So it picked R, X, Z. Just a little bit of randomization you can sprinkle in here and there. Another thing you can do that's fun with interactives is you can select from a list of words. So you can change like the storyline and something. So I'm gonna select from a list of animals. And what are our favorite animals? I like capybaras. What do you guys like?
Aardvark.
Hard. Thank you. I have no idea if that's right. Need one more.
How about a giraffe?
Thank you. All right, so it's going to be confused here because the default is that it's expecting a list of numbers or math objects, and I'm giving it this weird string. So I think it will actually select something here, but it will list it in a funny way. So we'll see what it does. And then I'll tell you the word. So, oh, no, just, for some reason I gave it a plural name. I don't know why I did that. Okay, so this is actually, it did select the word, but it's in math text. So it's thinking of it behind the scenes as A times R times D, blah, blah, blah. So what I really just want to use this in like maybe a word problem or something. So I'm going to do type equals text. And then change this to plain text. All right, so what else can we do? So that. All right, so I think what I would like us to do, I'll show you one more thing actually that we can do several parts. So the next thing I'd like to do is I have selected some different numbers, but there could be some overlap or there could be something that just breaks the universe for me, like 0. So I want to be able to select something that isn't something else. And to do that, you can use what's called an exclude. So we're going to go ahead and just do this together, modify B so that it can never be the same number as A. So I want B and A to be separate. And there is some overlap here. So I'm going to go ahead and just add in exclude equals, and then I need to use the reference. So I'll put $A. And this isn't going to be very exciting. We are already rendering these values, and I'm not looking at an example where they overlap, but you could run through, go through 100 variants and check and make sure that yes, they are in fact all independent if you want to. Okay, so that's that part. So we took care of this one. I'm going to comment that one out, and I'm going to let you guys work on work on the fruits, and then these parts that are modify C, B, and this number 4 we can do. Okay, so stop when you get to something that's asking you to pick multiple prime numbers because I haven't showed you anything with that yet. This is a lot of things, so we'll take 5 minutes here. It's weird. I didn't hear the little song. I don't know what happened. Um, Hopefully that wasn't too bad. Uh, did anyone have any struggles?
I'm just not finished looking up the array formation for multiple selections.
Oh, you're
I
working
mean,
ahead then. Like you're
well,
you're past where we were supposed to be.
oh,
So
I thought
that's
we were meant to pick multiple prime numbers and then I had to look something up.
oh no, I was gonna show you that and make
Oh,
that
okay.
easier. So yeah, you're good. All right. So the fruit thing, I'm not gonna demo that because I think everyone probably, knows how to do that now. So, but I will go through some of the next steps because if you got stuck on the thing that broke, I want you to see how I fix it. So, I want to modify C's that it can never be A, B, or twice A. And this is something that I think is really cool and that is not commonly understood is that you can actually do like math expressions and things inside your attribute specification with references, which can be really, really powerful. So I can actually do 2A here and that'll work just fine. So that's pretty cool. And then I also say modify B so that it always has to be greater than C. This is the one I did. Okay. I think I'm missing some exclusion here. Exclude A, exclude A, B, C. From, okay, so the way to modify B so to be greater than C is that my from is going to be C here. Or maybe C plus 1 I could do. But let's see what happens. So did anyone else run into this? Yeah.
Mine
Technically, I
actually
realized.
said mine actually said too much recursion instead of call stack size.
Okay, so like different browsers or something, it might be doing different, giving different error messages. But what's happening here is I'm referencing C within B, and within C, I'm referencing B. So it's just getting confused. This is actually when you have a lot of different things happening, this isn't too hard to run into because you're just not keeping track of like sequencing. You might change how you want to do something in the middle of your layout. So if I just get rid of this, because it's redundant anyway here, then that takes care of that. And this should actually be C plus 1. Okay. So if that happens, just be aware that there's some kind of like circular reasoning going on in there, but you can put math expressions and stuff inside your and you can change, the limits to reference things as well to sort of get things in order. Okay. So that takes care of that. A new selection that chooses a variable rather than a number. So I'll go ahead and skip that one too, unless anyone has any questions on that. How did you guys get it to not be the same, choose the same variable? Because exclude doesn't work here, unfortunately. I don't know if anyone ran into that. It would be nice if I could say, select name equals var 2, and then say exclude whatever var is. But because of the way select works, it's kind of too general for that. So it can't do that. So one easy kind of dumb way you could do it is just create a separate list of exclusive things, of exclusive choices. But sort of an even better way to do this is to change the number of selections to 2. So that wasn't what I was expecting you guys to do because we haven't talked about it yet, but you can change the number of selections on any of these variant creating components, basically. And then I'll show you what happens with when we update this. We're now going to get a list. So this is an array. It's picked T and Y. And the reason it works for I want 2 exclusive things by default it's going to pick things that aren't the same. And there's a way around that. There's another attribute. Let's say if you want to have, you know, pick 5 numbers from a selection from 1 to 3, you could do that. It'll break at first, but if you add on an attribute, it will be just fine with it. I forgot what that attribute is called off the top of my head. But by default, it's going to pick exclusive ones. So that's
Are you
how
thinking of with replacement and
with
without
replacement.
replacement?
Thank you. Yes. Okay. So we did 4, and now we want to modify the activity so that 2 prime numbers are selected. I'm just going to comment some more stuff out so that it's um, so prime numbers, and the component to use is num to select. We'll see what happens to our empty attribute num to select. Oh yeah, it's not happy about the fact that I didn't tell it how many. Okay, so now B is also an array. So if we want to use just one of these numbers, or refer to just one of these numbers, the way that we use that is using like array index notation, square brackets following our reference. So I'll just Control C, Control V this, and I'll say, if I want to know what the second element is, that could be the second element. So it just picks the second, and it indexes from 1. So if you're computer science mindset, have to forget that because everything starts at 1 and don't. Which I love actually.
Except for layers.
Layers, yeah, that's well, they don't care about layers yet. We'll learn about layers tomorrow. They only apply to graphs. Okay, so that's really nice. It's very powerful to be able to select multiple things. But what happens if you have 5 selections and then you're using it in equations all over the document? And I kind of wish that I had a really cool activity to illustrate this, because I'm throwing a lot of abstract things and just saying, trust me, this applies when you make something cool. Next time I'll have something more cool to show. But if I want to maybe select 5 things, it can be really annoying to say, okay, which one was that? The 3rd selected or the 4th selected? And you've got all these square brackets everywhere and all your math, and it's really ugly. So we used to have a different way of keeping track of things. We could just sort of like stick a name that you liked in there right within the component, but that doesn't exist anymore. So now we have to do a little bit of a longer stepwise. You first define what your bucket or your array of things, and then you kind of just give it a new name and say, hey, take the first element and call it this. Take the second element and call it this. So it's a little bit of extra coding, but it's not too hard to get it started, and then sometimes it can be very much faster than having to type in all of the indexes. So I'm going to just call this, I don't care about math expressions, I'm going to call it a number. And let's see what I say, QQQRST. Oops. T. And then I'm going to use extend, which is saying take the value. It's like a copy. There's copy and extend when you want to grab a reference. So I'm going to grab the reference from B, the first element. So P is going to be the first element in my array. So that way, everywhere I want to use B square bracket 1, I could just use shorthand P. And then I'm just going to do my quick and dirty copy paste. And so now this is boring to watch. I am sorry. But now this will be much nicer to write in my code. Okay, so questions on that. I should probably show you what this looks like here. Let's do a couple. So it grabbed the first element, it grabbed the second element. It just renamed them. How are we feeling about that? Does it make sense? Yes. Yes, exactly. It's just like a little bit, when you use extend or copy, it's a little bit shorter. Actually, you really find, I find myself using this more when I want to attach. I want to take the same object, like let's say a point or a line, and then I want to make it somewhat different. I just want to stick on an extra attribute, like copy this line but make it purple, you know. Then I can like add that attribute in and use the extend attribute. And copy does like, I want to copy that line, but then I want them, if the student drags that line around, I want them to be separate things now. I don't want them to go along with each other. So copy is like making a detached copy. Okay. So let's go ahead and work on task number 5. And that is, you're going to have to do a little bit of tedious typing, unfortunately, and create these variable names, these new numbers. And then we're going to try and combine everything you learned in the first session with Melissa and what we're learning here. So you want to create this multi-select. You got 5 things. And then on the left-hand side, you're going to make an equation. On the left-hand side, it's add all these things together. On the right-hand side, what is the sum? You could turn it into a question if you want, or you could just make the equation. Up to you. Let's take 5 minutes to do that, since you got to do a lot of typing.
I have a problem. It really doesn't like my number extend. I just pasted it in the chat, and have I got my syntax just off?
$B.
$B.
Forgot the
Oh, the
dollar
dollar sign. Thank you.
Yeah.
Yes, that's it.
It'll happen. It'll happen so often. Especially, at least you're starting from a position where you have to put it everywhere, but we used to have this. Sometimes it needed, sometimes you don't.
Okay, it is much happier now. Thank you.
Yeah. That's why we're cursed, Melissa, I think. I'm gonna stop. Can I stop a little early? That's evil teacher. Evil person. Is anybody ready for me to kind of go on? Feel okay? I wanted to share, and I know we don't have much time left. So the next task I'm gonna give you is like sort of more of an application task, but since we don't have a lot of time and this has been very abstract, I want to show you how it's used. Which maybe I should have started with, but just is what it is. So here's an example of a pre-calculus problem for law of sines where we have, a diagram, we have some angles given and a single side. We have a solution component that the student can check after they're finished. We have a worked example with different numbers, the same situation. And so under the hood, and as you can see here, this has variance. So if I change the variant, I'm going to get a whole different triangle. And the way this gets created, and Zoom is a little bit slow when you're using Donut on it, but 100 different triangles, and the way these get created is by using these selection components. So it kind of all starts with the problem of setting up what are good values for the different things in my problem that I want to vary. And you tweak those, you find the range of things that make you happy, that make things nice and clean for the student. And then once you kind of start, and maybe it's only, in this case, it's only 3 parameters, everything else gets constructed off of those. So you're defining your mass based off the references back to those things that are varying. And then, for example, in this problem, I have things that I want to display with certain decimal values. So I want to compute it with like a math. And a lot of times I'll have, this is my math thing that I'm doing over here, and then I'm displaying this thing on screen. So I'll just define it as a number with decimals there as well. So there's lots of things happening when you're just setting it up, but then you're also using references when you're rendering the problem. Those parameters they determine the graph size. You have big triangles, small triangles, and skinny triangles. And so the way you can actually use references when you're defining your coordinate axes limits. So I'm using references in my x max and my y max, and you can use math expressions in these. So it's really powerful how everything can be tied together based off a little bit of a data that you give it at the beginning. Same thing with all of the geometry that you're building. All of this is based off of the references, like you define some points, which refer back to the parameters that you started with. And then the line segments and everything tie off of those points. It's like a waterfall effect. That makes sense. So just wanted to share like how the magic of where you're going with this, because it's really dry when you're just defining shoes for numbers. So with that in mind, we'll do this task number 2, unless anyone had questions on how to do task number 1, or you want to see how I would do this last part.
I wanted to ask about summing a list of numbers.
Mm-hmm.
Is that because I see there's a sum
Yes, that's
tag?
the bonus. Good. Okay, so let me show you the bonus way. Where do I want to do this? I'll do this down here. Actually get something out of my testing block. So I want to, you could do math. I'm going to wrap everything in an M tag. I could do, I want my references. This is just for the student to see what they're summing. And then you could do the math simplify thing. There's two other ways that you could do it, maybe more, that I like for various reasons. So, like she was just saying, you could just do a space separated list. You can also give this a name. The sum thing could have a name. And so this is another way to do it. So that can be named, that can be referenced to elsewhere, use it just like a math. Um, there are several other components that are similar to that take, you know, and do some operation within. And then also something that John Rognus, who's like sort of a maestro of Donut ML here, he does a lot of like geometry stuff. So if you find his content in the wild in the explore when you're exploring, it's really sophisticated animations of the Pythagorean theorem and things like that. He uses, really, really complicated computations behind the scenes. So what he found is that if you define things as numbers, it takes less memory. So rather than doing math simplify, just saying number, it's going to evaluate what's inside the number tag and spit out one floating point number. So you can use that as also a shorthand for whatever thing. If it's something is going to result in a number, you can just stick it in a number tag. And oops, I forgot my pluses. You do need operands. It's unlike the sum tag. It's not just assumed. Okay, so there we go. That's the other ways, the bonus ways to skin the cat. But yeah, I think let's go ahead and work with the last couple of minutes we have on task 2. And you can just call out questions if you have them or post them in the chat. This is way over my head. I'm attempting to see if we have anything like that, Spencer, but yeah. Is this, the right library for what you're talking about? Pandas is just like that.
Uh, the one I was thinking of is like if you have array of strings, you can then specify what the separating character is when you concatenate them into a single one. So like by
Yeah.
default, Donut is outputting a comma separated list of numbers, but then uh yeah.
So I would say not sure. I know that we can do some limited string operations, but I do it so rarely that I can't really remember off the top of my head like what the components and attributes are. But let me get back to you on that. It's just doesn't come up as often. Um,
Yeah, no worries.
yeah.
I was just trying to be extra fancy.
That's very fancy. Okay, I didn't realize I was unmuted. I'm sorry. So we have about 5 minutes left, and you're probably still working on this task. But I just wanted to give some space for last questions or thoughts, ideas, things we should bug Dwayne to create. Today seems like it was a lot of information.
Is there a random number seed you can set? Because every time it was hard to test one of the questions you asked, like when I was excluding something, I didn't know if it had worked or not. And I would have liked to have seen 20 different outputs, but I didn't know how to get it to pick all over again.
So typically what I end up doing is like, and this is actually you're bringing up something that we've talked about creating before, and is that that's like some kind of variant tool viewer where you can see everything A to CV that got selected and kind of like compare and troubleshoot. Um, I think that's what you're asking for, like sort of a shortcut to like scrolling through A to B to C to see what's been selected. Is that true?
Just to have it make a different random selection from the one that it did, because it
Oh,
doesn't change when you run it, when you save it again, it doesn't pick new numbers or
oh,
animal.
yes, yes.
And don't worry if that's complicated, it doesn't really matter.
Oh,
Um,
there's the little button next to like A at the top of the viewing pane, the little down arrow, and
Oh,
that like quickly shows you the next set of selections, if that.
I
oh, where is
so
that?
yeah, so
I don't see that.
you may be satisfied with the fact that you can
Yeah.
do this. But and again, sometimes if you're trying to solve a complex, like, do I have a bad variant in here question, this can get really tedious to scroll through. So that's kind of what I was referring to. But if you just want to see a couple of cases, it's okay. Um, there is another kind of component called select random numbers, and this has a completely different mathematical thing going on. So for once you define your set of selections, a select is like variant A is always going to have B equals these five numbers, no matter what. The student's not going to know that they got variant A, but that's what it will be. At least if it's embedded in Donut, if you go and put it in some other tool, like take the same file and put it somewhere other tool, I've seen some kind of strange things happening, but that's not supposed to work. But there's also sample prime numbers, random numbers, things like that. What haven't I not used? S. And actually, I think I have used S. B. And I think this is defaults from 0 to 1, so we'll just give it like 0 to 10. Um, so what this is it's like it's going to actually every time you refresh the page, or you can actually have like create a button. It has the maybe you're doing some kind of like probability thing. You're having students like select things themselves, and then they can keep reselecting. So I got 9.31 because by default it's choosing a floating point. But then if I refresh it, I'm going to get something else. So just a layer different depending on what you're trying to achieve.
There's a thing I found in the documentation called like resample, like a
Yep.
call action thing. So you
Yep.
could like make a button, I guess, that picks
Yes.
you a new number.
Yeah, I'll show you how to do that. Let's pick. So all action.
Cameron shared a bit of code in the chat if you
Oh,
just want
is
to
it
copy
already
paste it.
there?
Yep.
Cool. Thank you. Yes. Mhm. So Dwayne tries to discourage me from using this. Oh, did I not? I need to give it. Yep. Didn't tailor it to my own. Um, Even though you could use this, there's a way to create this select discrete or discrete uniform or whatever. The distribution can be changed so that it's not picking a floating point number. So you could pick integers, and then you could just have the student click, 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 get a new problem, get a new look on that equation. I can't exactly say why he discourages that, but it's designed to be some like a feature that you would use an activity where a student is selecting in the context of randomization, teaching about randomization. But yeah, I think that's better soapbox for Dwayne to explain why he doesn't like really advocate for that. I think it has to do with repeatability and controlling like the outcomes that you have, because when you use a select, you can see everything that can be encountered by the student. No, but with sampling, you can't make sure that everything is good. That makes sense.
And on that note, I guess I'll put in my 2 cents. Uh, Randomizing problems so that students get different questions to each other does not mean that any number in the problem can be randomized. Or at least it ought not to be. So if you're trying to create equations, linear equations, for instance, where you want only integer solutions because fractions scare students, or you want to be equitable in terms of difficulty, perceived difficulty, that if half the class is getting integer solutions and the other half of the class is getting ugly fractions for various values of ugliness, there's going to be a minor revolt somewhere. So as you work through either the task that Virginia just shared, I forget if it was 2 or 3, and then the post-workshop tasks for tonight or for today, think about how you would select the parameters first, and then work your way backwards into the question, as opposed to saying, I'll offer a hint maybe very quickly. If you're trying to, say, pick constants in the standard form of a quadratic, so you're picking numbers for a, b, and c, you cannot guarantee integer roots if you randomly pick a, b, and c from some range. Right? So if you want to guarantee that every single student in the class gets something that they can actually factor, then you want to think backwards. And that, I think, is a fairly weighty hint, so I'll stop there. Think from what the outcome ought to be and then work backwards from it, instead of selecting the coefficients first, or the constants and the parameters in the problem first, and then trying to compute whatever the answer will be. Any closing thoughts, Virginia or Melissa?
Excited for graphing tomorrow.
Yeah.
That's where the fun is.
All right, then I'll, I guess, close proceedings for the day. There's a link in the chat that has the tasks for post day 2. And the second link is the place in the community discussions where you can share your links. Thank you for sharing the ones that you did. It was great fun looking at them this morning. So continue to do the same, and we will see you tomorrow at 3 p.m. Eastern.
Okay, bye.